Hey, what's up YouTube? In this video, I'll be breaking down this portable power station to show you guys what's inside and how things work and some thoughts about repairability. So stay tuned. Okay, so I purchased this power station a while ago just to benchmark my own battery projects against products commonly found on the market. Now, spoiler alert, I do have another battery video coming out very soon, so stay tuned for that. The reason I want to break this down is because I want to see what's inside, how it's built, how some things work, and also what kind of cells they're putting into there. So, these are things I'm very curious about, and I want to see how as I mentioned before, how my batteries stack up against, stuff like this. Now, another thing is, in breaking this down, there are no teardown manuals, there's no exploded diagrams that I could find, so I do risk breaking this, and I hope you guys appreciate this video, so I'll be taking some risk for this. Another thing is, I want to thank Power Extra for sponsoring this video. I reached out to them, and they sent me out this pack, and they, I explained my sole purpose is I want to break this down and see what's inside, and surprisingly, they're okay with that, so thanks to them. Now, let's go ahead and commence with the breakdown. So first things first, let's talk about the operation. Right off the bat, I can see that there's a screen over here. It's a standard LCD screen, and then there's various buttons over here, like there's AC, DC1, USB, and DC2. From what I can see, and also reading the manual, when you press these, I don't know if you can see on the screen over here, but it actually activate power to these individual ports and whatnot. So I'm gonna go ahead and shut off everything. All right. Now, I also noticed that, when I click these buttons, there's no internal clicking, so there's no electromechanical relay inside activating power to these. And that's, quite understandable. These don't draw a whole lot of power. And so, I don't think you'll need a mechanical relay. I do think a standard solid state relay should do the job, or a printed, relay assembly. Now, looking at the back, I can see some of the specs over here. I can see that the DC input requires 12 to 24 volts, and it did come with its own charger. The AC output, of course, is 110 volts, and it claims that it's a pure sine wave, and I might verify that in just a second. And you can draw a maximum of 300 watts, so that's about 3 amps. That's not that much, but I'm not too concerned about that right now. And it says that the internal lithium-ion battery capacity is 26 amp hours. I'm going to go ahead and put that to the test. Now, I don't know if they actually accommodate for whether or not this figure takes into account the 80% depth of discharge. And then it says the operation temperature is from 32 degrees to 95 degrees Fahrenheit. That's not surprising. Freezing temperatures aren't exactly great for lithium-ion batteries. Now on the side over here, I can see there's a cooling fan, and I assume that's probably for the inverter to convert the DC, battery voltage to an AC battery voltage. And then on the other side, I accidentally activated it. But on the other side, there is a small flashlight with a diffuser panel over here, and there are some openings to the side of it, so I think these are for airflow. So let's start with the breakdown. On the top, I can see there's 4 Allen screws. I'm going to go ahead and take these out. So interesting thing to note is that only the 2 screws over here had washers on them. I'm not exactly sure why, but I'll probably figure that out in a second. Okay, so I'm going to go ahead and lift off the top cover. And here you can see the internal workings. So over here, you can see the brains of the operation. As you can see, there's some heat sinks here with some MOSFETs. And over here, there's a transformer coil, which I assume is for the stepping up operation from the 12 volts to 110 volts AC. Over here, I can see an inductor element with some sort of paste over here. I assume this might be a thermal paste as it's up against the heatsink itself. And then over here I can see the main feed into the power. I assume this comes from the battery. I'm gonna go ahead and check that out. And then over here, actually there's some thicker cables over here. This actually might be coming from the main battery leads. Okay, so first thing I'm going to do is I'm going to go ahead and snip these cable ties. And by the way, this is a pretty dangerous operation, as you know, a mis-snip, being that these are metal wire cutters, they can short the battery, so be careful. I wouldn't try this at home unless you have the proper training. And first thing I'm going to do is I'm going to unplug this cable over here. And this looks like a standard, I believe this is a XT60 connector, which is honestly, in my opinion, that's a pretty good choice. I do like that. And then let's go ahead and plug this in the back. These thick cables also indicate these are probably the primary leads, so I'm gonna have to be careful with that. Now, I don't have any masking tape on me, so I'm just gonna go ahead and use some packing tape and just seal this off. Safety precaution. And I'm gonna go ahead and plug this cord over here. Not sure what this does, but I will figure it out. Okay, and let's see what else I can unplug. I can also unplug this cable over here. Again, not sure what it does. There's some weird caulk on there. This might be like a stabilizing caulk. I don't think this serves a thermal capability now that I look at it. And there is another cord over here that leads to the cooling fan. This looks like a 40 millimeter by possibly 20 millimeter fan. Pretty common in things like 3D printers or computers or server cases. I'm also gonna unplug this cord over here only because it's in the way. And now it looks like I can remove the control board, but before that I'm gonna go ahead and plug this cable. Now here's an interesting thing. This cable over here that goes over the top of the board, it looks like you have to unplug it from down below, because on this side it has the pins through soldered on this PCB board. So I'm going to try to slip out the board on this side diagonally. So I'm going to go ahead and remove these screws. Okay, now it looks like I can remove this. Doesn't seem to be anything holding it down. And here you go. Okay, so now the control board is out. We can take a look at it. I can see that there are IC chips over here. These actually might be controlling the displays, being that it has a close proximity to this plug over here, which led directly to the display. So we're going to set this aside and we're going to try to break into the actual battery itself. Something that's odd, and I don't know if this is like an afterthought in design, but it almost looks like they melted this corner over here. Maybe it was like an error in production, but that's kind of strange. But I can see the two main cable leads for the battery down below. I'm not sure if you can see that in the camera. And I'm gonna go ahead and try to extract this battery without blowing this up. So quick update, I peeled back these pads a little bit on the bottom, these friction pads, and I found there are screws below it, which I kind of suspected, because if you can see over here, I can wiggle this front panel a little bit. So I suspect by loosening these two bottom ones, I can take out the front display, which would be really helpful. Okay, and now that I removed the 4 screws on the bottom, let's go ahead and see if I can remove the base. I'm going to set this up right. Oh, and there we go, and display fell out too. So now we can see the battery over here, and it looks to be mounted by these 4 screws right here. So we're gonna go ahead and take these out, set the base plate aside. I can see that there's also 2 screws, or rather there's 4 screws over here. This might also release the battery. Okay, so now that I removed the 4 screws, I might be able to wiggle this battery out, and it looks like it's coming out. So I was incorrect before. The battery management system, or BMS, is located on the battery itself. Now, for such a large size, power station, I'm actually surprised. There's quite a bit of empty space in there. I think they could have fit a few more, batteries in there. Now, right off the bat, what I do like is it looks like the balance leads, rather than having small, thin wires, which are prone to, having their solder joints broken off, they have these large pads over here by which to solder the like I said, the balance lead. So that is a good, nice feature. And from looking at this over here, it looks like this lead over here is the regulated power from the BMS, and then these two are the unregulated power. So I should be careful with that lead. I'm gonna go ahead and wrap that lead up with some tape. So as I mentioned before, the 3 screws, small screws over here, weren't for holding the battery in as much as it was for retaining these little, I guess you could say, bars that have foam at the bottom. This is for, well, it seems to be for retaining the battery itself. So I'm gonna go ahead and remove this. Okay, so now I've removed all of those 6 screws in total. I'm gonna go ahead and remove these little retaining bars and set them aside. They all seem to be symmetrical, so I don't think order really matters. Another thing I'm gonna do is I'm gonna go ahead and unplug this cord over here. I can see that there's a TX RX ground key, BT, and charge AWAC. So I assume this is the, well, I guess this comes from the IC chip on the BMS and communicates with this board so converts data to visuals. Okay, I think I might be able to shake this out. I'm gonna go ahead and give that a try. Oh, there you go. So here is the battery itself. And right off the bat, just from seeing the corner over here, I can see that these are 18650 cells. Now, what I do like from this is that a lot of manufacturers, they use that, you know, high temperature tape over here. But here they're actually using like solid high temperature barriers and whatnot rather than tape. And not only is it a lot more cleaner look, but it does seem to provide the battery more shock protection. So that's quite interesting. Now, I'm going to go ahead and see if I can peel off one of these and see what's underneath. Okay, so I finally got the side panel off, and it seems to be held on by some high temperature hot glue, which is pretty standard. Now, looking at the battery cell itself and the identification number, here you can see it's H18650CQ. Now, I looked up the battery spec online, and it's actually pretty respectable. So this battery, of course, is an 18650 battery, and you know, so 3.7 volts nominal. It's rated for 2,550 milliamp hours, which is pretty respectable, right? But what's interesting is that this is rated for 3C. So its discharge is 3 times 2,550 milliamps. So that's roughly 7.5 amps. Now, these batteries are normally used for, like, you know, cheaper e-bike battery packs. So, you know, for a power bank like this, that's, you know, that's pretty good. Now, another neat thing I noticed is just from this little corner over here, I don't know if you can see it, but this is the positive side and this is the negative side, right? So a good practice is to put these little fiber discs or like isolators on the positive side just to ensure that nothing accidentally touches bridges between the positive port and then the negative case itself. So that's good on them. This is a really good quality control kind of deal. So I'm gonna try to peel off a little bit of the this top panel over here just to see you know, how they spot weld or solder these cells together. Now, another thing I want to note is that you can see there's 3 cells over here. Based off the pack specs themselves, it looks like there are 3 in series and then 10 in parallel. So a total of 30 cells. So, you know, 3 times, well, the maximum voltage of 4.2 would be 12.6 volts. So that's good. And then, you know, 10 in parallel, then you go ahead and you, you know, add up all, or rather multiply all the capacities together. Okay, so I peeled up the top panel a little bit. I didn't want to peel it all the way as to not compromise the pack integrity. But I do see that they use a prefabricated nickel strip with little strips over the poles themselves as to, you know, ensure that there's a good spot weld. And you can look up a lot of videos into, you know, spot welding techniques, and you understand why this little cutout is important over each pole. Now, something I also noticed is that there's a slight tiny bit of, I guess, reddish discoloration over each of the spot weld joints. This tells me this is not a pure nickel strip, but rather a nickel coated, probably an iron or steel strip. So, you know, while it does, you know, lead to a little bit more impedance, it's not such a huge deal in this non-critical application. But overall, I do like the construction, especially these, you know, protective pads themselves. Now, I also noticed that there's these 2 small wires over here, or it's rather 4 small wires. I do believe, based off their location, that these are temperature sensors. So it does lead me to believe that there is a thermal overload protocol for this whole pack. So, overall, I do like this pack itself. There are a few improvements I'd like to make, but we're going to circle back to that. I'm going to put this all together and we'll discuss that. Okay, so before I put all this back together, I'd like to talk about repairability. So while the disassembly process was pretty easy and really all I needed was a screwdriver, replacing the actual cells inside the pack may be a little bit more difficult for those of you who aren't so mechanically or electrically inclined. And not to mention, you'll definitely need a spot welder. Now, I happen to be part of a Kickstarter by a guy named Julian LeMay who's making a portable spot welder. I think it goes for something like $60 or $90, which is a fraction of the price of regular spot welders. And not to mention, it's handheld, which is a huge plus. I'll post a link in the description below if you guys want to check that out. I know that he's starting deliveries pretty soon. I know there's some delays, but I'll be hopeful there. I do own a spot welder, as you've seen from some of my other videos, but just a heads up, if you do want to replace the cells, you should not use a soldering iron. You should use a spot welder. So, if you don't plan on getting a spot welder, you might not be able to replace the cells in here. But if you do, or you already have one, I think replacing these cells should be a breeze. And optionally, you can replace them with, higher rated capacities. So check that out. Okay, so I finished putting together the pack, and as you can see, everything works fine. The display works fine. The individual functions work fine. That's good. Now let's talk about the overall impression I have of this pack. Overall, I do give this pack a 8 out of 10 for design. There are a few things I don't like, and there are some things I do like, and let's talk about them. First off, let's start with what I don't like. The number one thing I don't like is that there's a lack of fusing here. So there's a lack of cell level fusing, and there's also a lack of like a main central fuse. As a rule of thumb, you should never depend on the BMS, which of course has thermal runaway and overloading protocols for protection. You should always put in some sort of fusing for safety. Now, if you've seen my electric car battery, you'll see that I have cell level fusing and also a central fuse, well actually multiple ones of them, in order to, avert from disaster. In this case over here, they depend on the BMS, which of course, as I mentioned before, there's thermal runaway and overload protection protocols, but you should never really depend on that, because if the circuitry fails, then you got a big problem there. In my case over here, I'm probably going to be soldering in a fuse of my own just to be safer, but as a note to the manufacturer, you might want to fix that issue. The second and last thing I didn't like about this pack is the fact that there's no master cutoff switch to disable power to everything, including the display. The display will always have power running to it, or rather the switch behind it. As we saw from me disassembling this pack, there's always unregulated power flowing to the this PCB board right behind here, and that may be a little bit of safety concern if this becomes somehow submerged in some sort of liquid and whatnot. I know this is not rated to be waterproof, but I do believe that a master cutoff switch would have been a smart move. Now let's talk about what I did like. So many times when you go with cheaper manufacturers, their wires are usually like just red and black, and they solder it from one point to another. There's no, connectors and whatnot. In this case, there's a lot of good connectors here. Those XT60 or XT90 connectors, those are a huge plus in my book. They're not only easy to disconnect, but they do carry a lot of current without melting and whatnot. I know this carries less than 10 amps on those wires, but it's still a really good idea. Not to mention those other smaller connectors like the JST standard connectors, those are a dream to work with. So there was really no cutting or desoldering anything to take this apart. It was all plug and play, and that is a huge plus. The other thing I liked, as I mentioned before, is on the battery pack itself, it used those solid panels on the sides rather than the cheaper method of using high temperature Clapton tape or like a shrink wrap. That shows that the manufacturer has some dedication to safety there. Not to mention the way that the battery pack is held down with the foam. That's a huge plus. It does mitigate some shock if you ever drop this, though I wouldn't recommend you drop a lithium-ion battery, but it is there, so that is a good feature. So overall, I do like this battery pack a lot. There are a few design issues that I didn't like the fusing issue, which I will go ahead and repair myself. But I will be using this in some of my filming projects and maybe some camp outings. And again, special thanks to Power Extra for sponsoring this video. If you guys like this video, please consider liking and subscribing. And if you have any questions or suggestions for future content, please leave them in the comment section below. Thanks for watching, guys, and I'll see you next time.